So everything I just explained to you about, like, figuring out unions and how you have to subtract the intersection, add up all of this circle to this circle, and then subtract the intersection once, whether it's like total number of people or the probability of this one and the probability of that one and the probability of the intersection, right? Like all of that stuff that we just went through, and we saw it right here with this formula here. This formula here, our textbook calls this formula the addition law. And so this is exactly the same formula, PAB, PA intersection B, PA, PB, P intersection A, the A intersection B, right? Subtracting it. So yeah, our textbook calls that the addition law. Okay, like whatever. I like much better getting there through just logic and thinking about it. And so here's another example of calculating a union. And they say here applying the addition law, right? Which is like just calculating the union. A small assembly plant with 50 employees carries out performance evals. Each worker is expected to complete work assignments on time and in such a way that the simple product will pass final inspection. The results are as follows. Late completion of work, 5 employees. Defective work, 6 employees. Late and defective, 2 employees. So there's the frequency. So I'm thinking that we're going to have like, here's like, the probability of event A that your work was late is like 0.1. And so 0.1 is 5 out of 50 or 10 out of 100. This is 6 out of 50 because there's 50 employees, or 12 out of 100, 12%. This is 2 out of 50 or 4 out of 100, right? Or 0.04. And so here we have like how many employees had, late, defective, or both. We would say, okay, we're going to add up the probability of this to this, and that's going to be like 0.22. And then we're going to subtract the intersection once, right? The intersection is where they had both. These are overlapping circles. So it's 0.22 minus 0.04. It's going to be 0.18. And so here's the event that the work is late. Here's event D, it's defective. And then down here, we do the union of that, probability of late, probability of defective, minus probability of the intersection of late and defective, and we get 0.18. So that's just another example of doing a union, but it's here in the presentation, so I thought I would go over it with you.